Your HVAC system is probably the most expensive thing in your house that you never think about. We're talking $12,000 to $15,000 sitting in your attic or basement, quietly working every day. And here's the problem. The industry knows something about your system that they're hoping you never figure out. Since 2020, HVAC prices have jumped nearly 40%. You'd think for that kind of money you'd be getting better equipment, but the opposite is happening. One say quality has actually declined, and there are 3 specific reasons why the system you just paid a fortune for might not last more than 7 or 8 years. I'm going to show you exactly what's going wrong, why it's happening, and most importantly, what HVAC technicians actually install in their own homes. Because it's not what they're selling you, let's start with the biggest scam in residential HVAC right now. It's called flex duct, and there's a good chance your entire house is full of it. Don't walk into any new construction home built in the last 20 years and look up in the attic. You'll see these long, silvery tubes snaking everywhere. They look kind of like dryer vents, but bigger. That's flex duct, and builders love it for one reason. It's cheap and fast to install. A crew can duct an entire house in a few hours instead of a full day. But here's what the EPA found when they actually studied these systems. Flex duct loses between 20 and 30% of the air that's supposed to reach your rooms. Think about that for a second. You're paying to cool or heat air, and up to a third of it is disappearing before it ever gets to you. It's leaking through connections, it's getting trapped in sags and kinks, it's bleeding through the material itself, and it gets worse. Flex duct is basically a plastic bag wrapped around a wire spiral. Over time, that plastic degrades, it cracks. The inner liner separates from the insulation. Mice love to nest in it, and once any of that happens, your efficiency drops even further. The National Comfort Institute went out and tested hundreds of residential systems in the field. What they found was brutal. The average home was only getting about 57% of its rated airflow. That means if you bought a 3-ton system, you're getting the performance of maybe 1.5 tons. Now, here's where the industry's incentives get really twisted. When your system can't keep your house comfortable because half the air is disappearing in the ductwork, what do most contractors recommend? A bigger system, more tonnage, more money, and the cycle continues. Meanwhile, commercial buildings, hospitals, office towers, they all use rigid metal ductwork, because when you actually care about performance and longevity, that's what works. But for residential customers, flex duct. Because it's cheaper to install and the builder will be long gone by the time the problems show up. But faulty ductwork is only the first problem. The second one is even more frustrating because it's happening before the system even gets installed. There's a calculation that every HVAC contractor is supposed to do before sizing your system. It's called a manual J calculation. It looks at your home's square footage, insulation levels, window types, orientation, local climate, everything that affects how much heating and cooling you actually need. Here's what the National Comfort Institute found. Fewer than 1% of HVAC contractors actually perform a proper manual J calculation. Less than 1%. The vast majority just look at square footage, maybe glance at the old system, and round up. They call it rule of thumb sizing, and they almost always round up. Why? Because an oversized system still cools the house. The homeowner feels cold air coming out of the vents, so they think it's working great. But what's actually happening is destroying the system from the inside. When an air conditioner is too big for the space, it cools too fast. It runs for a few minutes, hits the thermostat setting, and shuts off. Then it turns back on, then off again. This is called short cycling, and it's murder on the equipment. Compressors are designed for long, steady runs. They're at their most vulnerable during startup. When refrigerant pressures are equalizing and the motor is pulling maximum current. An oversized system might start and stop dozens of times per day instead of running a few longer cycles. Every single startup adds wear. The compressor, which should last 15 to 20 years, burns out in 8. But wait, there's another problem with short cycling. When your air conditioner runs for only a few minutes, it doesn't have time to dehumidify the air. Cooling happens fast. But removing humidity takes longer. So you end up with a house that's cold but clammy. That sticky, uncomfortable feeling that makes you turn the thermostat even lower, which makes the problem worse. And here's the really frustrating part. When that oversized system dies in 8 years instead of 15, the homeowner usually blames the brand. Must have been a lemon. They buy another one, same contractor installs it, same rule of thumb sizing, and the cycle repeats. The contractors know this. The manufacturers know this. But nobody has any incentive to fix it. The homeowner doesn't know enough to demand a manual J calculation. The contractor makes more money selling larger equipment, and the manufacturer gets to sell 2 systems in the time one should have lasted. Now we get to the third problem, and this one is about to hit everyone whether they like it or not. The refrigerant transition. For years, the standard refrigerant in residential air conditioning was R22, which everyone called Freon. It worked great. Then we found out it was destroying the ozone layer, so the industry transitioned to R410A, which they marketed as Puron. That transition took about 15 years and drove up costs significantly. But here's the thing, R410A turns out to be a powerful greenhouse gas. So now there's another transition happening. Starting in 2025, new equipment must use A2L refrigerants, primarily something called R454B. This is going to affect you in several ways, none of them cheap. First, R454B is classified as mildly flammable. It requires different handling procedures, different equipment, and contractors need new certifications. That means installation costs go up. Second, R454B operates at different pressures than R410A. You can't just swap refrigerants in an existing system. When your current system dies, you're buying entirely new equipment designed for the new refrigerant. Third, and this is the one nobody's talking about, there's already a technician shortage. A CHR News reports the industry is short over 110,000 qualified technicians. Now add mandatory new certifications for a mildly flammable refrigerant. Training takes time. Not everyone will get certified. The shortage gets worse. What happens when demand stays the same but supply of qualified labor drops? Prices go up. Service wait times extend. And the companies that remain get to be pickier about which jobs they take. If your system is more than 8 years old, you're probably looking at this transition whether you planned for it or not. And the homeowners who wait until their system fails in the middle of August are going to pay the panic premium. So what's the solution? What do HVAC technicians actually install when they're spending their own money? First, they insist on a proper manual J calculation. This isn't some fancy premium service. It's basic engineering that takes maybe an hour. Any contractor who refuses to do one or who wants to charge you extra for basic math is telling you something important about how they do business. Second, they think hard about ductwork. If flex duct is the only option, they make sure it's installed correctly. No kinks, no sags, proper support every 4 feet. All connections sealed with mastic, not just taped. But given the choice, many technicians will spend the extra money on rigid metal ductwork in critical runs. Well, especially the main trunk lines. It costs more upfront and lasts decades longer. Third, a lot of HVAC professionals are installing mini-splits in their own homes. These are the wall-mounted units you see in hotels and newer apartments. There's no ductwork at all. Refrigerant lines run directly from an outdoor compressor to indoor air handlers in each zone. The efficiency gains are substantial because you're not losing air in ducts. Each room can be controlled independently. Now, and because there's no ductwork to leak or degrade, the system maintains its efficiency over time. Mini-splits aren't perfect for every situation. They look different than traditional vents. The upfront cost per zone can be higher, and you need a contractor who actually knows how to install them correctly. But for many homes, especially older ones with problematic ductwork, they're the better long-term investment. Fourth, smart technicians are thinking about timing. If your system is working but getting old, the next 2 years are probably your window to replace it on your terms, rather than in a crisis. Equipment prices are only going one direction. The refrigerant transition is going to create supply chain chaos, and that technician shortage isn't getting better anytime soon. Here's what it comes down to. The HVAC industry has gotten very good at selling you equipment that's cheap to install and expensive to live with. FlexDuct saves the builder money, or not you. Oversized systems are easier to sell than properly sized ones, and the refrigerant transition is about to scramble the entire market. The homeowners who do well are the ones who ask questions, who demand manual J calculations, who understand that the cheapest installation often leads to the most expensive ownership, and who make decisions proactively instead of reactively. Your HVAC system doesn't have to die in 7 years. But it will if you let the industry treat you like every other customer. If this was useful, you should see how the same cost cutting is affecting another major home system. That video is on screen now.